Welcome to the session. Greeting of the day. In today's class, we are going to see about the various pneumatic actuating systems. We have seen in previous classes that in the actuating drive mechanisms, drive or actuating systems, we have divided into electrical actuating, mechanical actuating, then hydraulic actuating, and then now we are dividing into the pneumatic actuating systems. Now we are going to see about this pneumatic actuating systems and their few types. Next I am coming to some other type of diaphragm compressor. It is also very important one. A small capacity compressors. This piston reciprocates by the motor driven by the crankshaft. We understand here, you see, it is a combination of fluid and air. Here the fluid is coming in. It is a pneumatic system, I told you. We are operating the fluid. This air circulation takes place only at this spot. You see, here, this spot means only here. Above this spot, above this spot. Okay, so we understand. I have a setup as like the inlet of hydraulic fluid here in this direction, hydraulic fluid, and I'm operating inlet, and it is going to hydraulic fluid going to take out here. In between, I have several ports, port 1, port 2. So I have some few ports, port 1, port 2, port 3, port 4, port 5, port 6. With all these micro ports, when the piston is reciprocating takes place up and down. When the piston is reciprocating, piston is operated to motor. When the piston is reciprocating up and down, this fluid is pressurized well. When the piston is going forward, fluid is going to pressurize through this micro ports. What happens? It is compressed. Hydraulic is compressed. This compressed hydraulic have a pressure. That the pressure is going to push the diaphragm which is present there, a metallic diaphragm which is come to the original position, and it is elastically extinguished when pressure is applied. Such diaphragms I am using here, and when the pressure is applied, this diaphragm is going to move upward and it is going to cause the pressure. This compressed fluid is going to cause the pressure on the diaphragm, and diaphragm is trying to move what is available there. Because the diaphragm is pushing here, diaphragm should move. What is available there, that also will move. What is having there? There I am supplying the inlet. There I am supplying the air inlet. It comes only downward direction. And when it is pressurized here, it is pressurized to happen here. This diaphragm pressurized to happen, and it goes upward. And it goes in the upward direction. So what happens here? Air inlet with normal pressure is given by the hydraulic fluid by the piston pressure. Diaphragm receives the pressure. That diaphragm pressure is transferred to the air, and in the outlet I have the high pressure. I have the high pressure air. So likewise we can able to utilize this diaphragm compressor. Same piston, same reciprocating action, but in the middle I am supplying the fluid to increase the pressure. The piston reciprocates by a motor. Yes, by a motor driven crankshaft. This one. As the piston moves downward, it pulls the hydraulic into the cylinder, into these cavities. Flows fluid down, causing the diaphragm moves along the air sucked in. Right. when the piston moves upward of the fluid, when the piston moves upward of the fluid, it pushes the diaphragm with the pressure of the fluid. Diaphragm is going to take upward direction when the piston is also moving upward, causing the ejection of the air from the outlet pore. So here it is getting ejected. So likewise we can able to tell this causing of this diaphragm compressor. This is one of the other type of compressors. A screw compressor. A screw compressor next. A very simple mechanism, you see. Here we have as like a motor driven shaft. Motor driven shaft. We have a motor driven shaft. What happens? This shaft, one is a driving shaft, one is a driven shaft. It means on one I am connected the motor, it is going to run, and another I am connecting through a screw. This is one screw. Screw threads are there. I am meshing one more screw over there, like a wheels. Like a wheels I am connected there. Now one I am rotating. Obviously one more also will rotate along with that driving shaft. One is rotated through motor and it is started to rotate, and here I am connecting one more screw and it is also rotating due to this driving force of the motor. Now in this driving I am inletting the air. See, the air is inletted here. This air inlet wanted to travel through this screw. And finds the threaded gaps and it comes down and it comes here and it is wanted to take exit. What happens here? Air is coming freely and it is compressor processes takes place by using screw threading action, screw rotating action. So air is compressed not by the piston, not by the reciprocating process, but by the screw actions. So this is the outer casing. So this is having the outer casing. Inside we have two screws, and one is driven, one is driving, and it is rotating, one is rotating. Right? And when it is both are rotating, the air should comes in, and when its air comes in, it goes through this screw caps, and again it comes out. So it's one of the easiest method to increase the pressure of the air. For medium flow pressure applications, here as like reciprocating compressors, it is not gives high pressure like 50 bars, 70, 100 bars, but for it will be useful for medium flow of pressure applications. A simple in construction with less number of moving parts. The air delivered is steady with no pressure pulsation. Pulsation means the change in pulses will not happen. The uniform flow, as because the thread are uniform, given inlet is uniform, and slowly it is rotating. Slowly it is at medium rate. It is going to give the exusions of the exit of the air. Two meshing screws. It contains the two meshing. So this is one meshing. This is one. Two meshing screws are connected by the driven. The air from the inlet trapped between the meshing screws and it is compressed oil free. Compressed, okay, and it is oil free also. It is useful in food processing plants, automated manufacturing systems, jackhammering, riveting tools or screws, fastening machines. So some all applications are there. In such a way, it means we need action at the other end. Air is coming, air is going out. This is to be controlled by the load. What is to be pressurized? Here we can have the control valve. Here we can have the control valve. Maybe port A, port B. Whether this outlet to be connected to A, or otherwise this outlet to be connected to the B. Accordingly, if the A is operated, the piston will move in the downward direction. The B is operated, the piston may move in the upward direction. Likewise, we can able to connect this. So this outlet can be connected to maybe A, or it ways by B. When it is operated through A, the piston will move down. When it is operated through B, the piston is going to move upward direction. So likewise, we can able to plan some other output actions. So these are some things. Next, I am coming to the rotary vane compressor. The principle of operation of the vane compresses a similar type of hydraulic vane pump. It's also same as like hydraulic vane pump. What it is? The unbalanced vane compressor consists of a spring-loaded vane sitting on the start of the rotor. You see, a cylinder, a tank which contains the inlet and which contains the outlet. Now, here we have this rotor is going to rotate, but how this rotor is made? There is a large gap is created at one side. It means the rotor is smaller than that of the outer frame, outer casing. How it happens? The spring is going to extend. This is this insert. You see, I am marking. This is the insert width of the spring. When the rotor is rotating here, this is going to take this many volume of inlet here. Now, this volume is again taken here. So let us consider this is a piston as a spring return which is available at this stage. Here it is closing in this volume, and here it will be. So when this is rotating like this, here we are getting is this volume. This volume of air is fixed there, and this volume of air is keep on moving. After this condition, what happens? You see, this is again it is slowly reducing. The spring action, it is expanded, and when it is coming in the another half cycle, it is going to compress because no space is there. Air volume is inside. It is wanted to compress those action. It takes place. Compression takes place in the half cycle. Compression takes place in the half cycle. See here. This I am drawing here. I have drawn. This having a spring here. This having a spring here. Now what happens? Now inlet takes place. This volume, this is the volume of the air. So volume of the air, this one. This is the volume of the air. It came in. So next, similarly volume of the air is here. Similarly volume is high here. So here volume is high, very large volume is there. Now, this piston is moved from this position 1 to position 2. What happens? Or position 3. What happens? This compressed air is going to compress here because here the length is high. Here the length is small. Here the length is small. Here the length is small. But there is no way to escape of this air. This escaping is blocked by this spring. Escape is blocked by this spring. Because spring is going to come out. Spring is going to come out. Therefore, there is no chance of escaping of air or leakage of air. But this air is compressed by using this rotor and the vane alignment of vane mechanisms. So when this shaft is going to rotate slowly, this volume of air is compressed, keep on compressing. And then when the outlet is come, it is going to release at a high pressure. Here we have high volume, the shaft is rotating and it is not finding the equal space. Therefore, the air is compressed by itself within the space allotted and it is trying to escape when the outlet port is came. What happens? Compression takes place here. Therefore, we are getting more pressure at the outlet. Normal air coming, volume occupied, spring return, space reduction, then compression, it goes out. It's a simple mechanism. The unbalanced vane compressor consists of spring-loaded vanes sitting in the slot of the rotor. The pumping action occurs due to the movement of the vanes along the cam rings, and therefore the rotor is eccentric to the cam ring. They free from the pulsations also. We have seen about the general filters, compressors, reservoir tank, control valves, and then the actuating mechanism of a piston. And then with respect to that also we have seen about this various types of compressors, such as this various piston compressors, double compressors and multi-stage compressors, and diaphragm, screw, those things we have seen. You see now, the main principal operation here takes place is compression. In this rotary vane compressors, here we can able to see the inlet takes place at this point, and it consumes more volume of air. I am telling here, this in between these two strips we have volume has been filled here, and this is operated by a spring mechanisms. Right? When this shaft is rotating, the rotor is rotating, this volume have to move to this side, and this volume have to move here, and this volume have to come here and take exit. Now let us consider it is moved from the position 1 to position 2. Now you see the volume is taken, volume of air is taken, but when it is moving towards that side, here you can able to see a small crescent zone. A crescent, it looks like a crescent, a 3-day, 4-day moon. A crescent you can able to see. This zone is crescent. So at here is crescent is less, here the crescent is large, and again it is decreasing. Similarly, here the occupied volume is large first. Inlet volume is large, and it is this high volume is compressed at the stage 2. At stage 1, high volume is there, and stage 2, the same volume of air is compressed in such a way. You see, in such a way it has been compressed. This is compressed one. This is the compressed one. Again, further, again it is coming to the present, it is compressed. Again, when it is coming out to this point, you see, here at this point, it is totally more compression takes place. At the compressed state of reduced volume, it is going to take exit. Therefore, the same volume, it has been compressed, and the same volume compression takes place again, and the same volume compression, and it taking with the high pressure. So our intention, we need more pressure to actuate. That is achieved through this rotary vane pump. So it is a rotary vane pump where the various number of vanes. This is a vane, this is 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 vane. Vane contains the spring return. When again it is coming in this side, the springs comes out as it can able. There is a lot of space to come here. Therefore, it can come in this side. It can hit it. When there is no space, it is going to take return back, and it's again it is come out. So likewise, this vane works. Next one we are going to talk about the lobe compressor. The lobe compressor. It is like that grown out shell we are using. The similar pattern where I need a high delivery of volume, more volume of air flow is needed. But this lobe compressor can able to create only the low pressure. So where is the application of high volumes required? At the same time, where is the application of low pressure is needed? These are all possible by this lobe compressor. What is the arrangement? It contains of two lobes. This is one. This is one. And this is 1 and 2 are there. What happens? Here the inlet is coming. It cannot able to pass through this wire. It is tightly, lobe is tightly bonded and permitting the flow not to go straight, but by using this path, when it is rotating, one lobe is rotating in the anti-clockwise direction, one lobe is rotating in the clockwise direction. Therefore, at two directions, we are receiving the flow of compressed air in this route. In this route, when this is moving anti-clockwise, along with that, this will come here. See how it will become. It will become like this. Right? So this volume is taken. This volume is taken. This entire volume. This entire volume is taken there. A large volume is taken there to the outlet. Again it comes, it rotates, goes, similarly it goes. So here what is the volume? This volume has been taken. This volume has been slowly taken to the outlet. So accordingly it moves. Accordingly it both moves, and here the one problem is friction is created. Friction is created, those points, these points are frictions are created. Therefore, it's to be taken care. So one being at the driven, one being the others driving. So one I am connecting to the external motors. In such a way, one can able to rotate. At the same time, one is also moving along with that. The operating pressure is limited. The operating pressure is limited, low pressure. Leakage between the rotor and the housings. The dynamic compressor, I am telling, see, a simple method of turbine rotation of this we are using here. A large volume of compressed air is required in the applications such as ventilators, combustion systems, pneumatic power blowers. We use this. The pressure need is very low. In such applications also we are using. How? See, we have impellers to rotate like this. It is one view, it is one different view. See, impellers are there, and now the inlet of the air inlet comes here. The same inlet type we have seen there also. In the hydraulic pumps also we have seen centrifugal force created in such a way it throws outside. Therefore, here also same. Instead of centrifugal pump, I am naming this as a dynamic compressor. So what happens? It is the impedance rotating along with the impeller. This inlet flow of air is going to travel. It is going to travel and throw, because from the center it is keep on throwing outside by the centrifugal force. This force makes the air to take to the outer part. From the center it is received and is rotated and thrown outside with high force of high pressure. So we can receive. If it is impellers too slowly running, slow move, or pressure is less, high speed, pressure is high. So such cases are possible in this case. So that is named as a dynamic compressor. Impeller rotates at high speed. Impeller rotates at a high speed. The blower draws the air in. The blower draws the air in. It's coming inside, and the impeller pinches it out due to centrifugal forces. So this is in the hydraulic. We have seen the centrifugal pump. Here also centrifugal compressor or dynamic compressor we can tell. The summary. In today's class, we have seen about the various types of pneumatic systems, the various components of system, pneumatic system, and these are the types of compressor. Likewise, a piston compressor. Likewise, a multi-stage compressor. The remaining part of the subjects we'll see you in the next session. Thank you.